Okay, right, this is your next question. So what I'd like to do is read the question, pause the video and work it out for me, please. When you're ready, unpause the video. Okay, right, here we go. So in his wardrobe, Jim has 8 green and 4 blue loose socks. Okay, Jim takes 2 socks at random from the wardrobe. Okay, now this is a pretty important life question anyway. Okay, the fact that someone's got green socks, that's by the by, but the fact that the socks are just loose in their cupboard, okay, obviously they haven't got a very efficient method going on. See, when I wash my socks and I dry them, I normally pair them together and I don't just sling them in the cupboard hoping I can just randomly select them, okay? Because what Jim is doing is he's obviously waking up late in the morning, he's not turning the lights on, it's dark, and he's just randomly fumbling around in his cupboard trying to find a pair of socks. And what he's doing is he's choosing one sock, okay, and then he's choosing another sock and then thinking, nope, don't match, then he's having another go. That's clearly not the best way of doing it, is it? Okay, so just notes to that, okay? For simplifying your life, try and pair the socks together before you actually put them into the cupboard. Right, let's have a go at this question. So what you want to do is look at what is going on for his first selection, okay, and you can either get a green sock or a blue sock. Okay, so there's 8 green socks out of a total of 12, and there's 4 blue socks again out of a total of 12. Okay, he takes 2 socks at random from the wardrobe. Okay, now a bit about life yet again. If you are like Jim, and I hope you're not, okay, if you are like Jim and you're just taking a sock at random, when you take your next sock, do you put your first sock back again? The answer, I really hope, is no. No, you don't. This is a without replacement question. It does not say so in the question, but you have to make that assumption. You have to assume that Jim is choosing a sock, keeping it, and then choosing another one. Who in their right mind would actually choose a sock, put it back, and then choose another one? Because what you're doing then is just wearing one sock to work, and that would not do with it. Okay, ladies and gentlemen, that would not do. Okay, so in Jim's second selection, you've got to make the assumption that if he chooses green the first time, the probability of choosing green the second time is 7/11. I'm hoping I've made that clear for you as to why that is. And then the blue will be 4/11. And then for the next possibilities, if Jim chose a blue sock to begin with, then the probability of choosing a green sock is going to be 8 out of a total of 11, and there's only 3 remaining blue socks, aren't there? So 3 lengths. So that is your tree diagram. Okay. Next, let's answer the questions. Probability that Jim selects 2 socks of the same colour. Well done, Jim. You've got 2 socks of the same colour. Okay. So that's going to be green. So that's 8/12 times 7/11. Again, green socks. Come on. That's not on, is it? So yeah, I better focus here so I don't forget how to do the multiplication. And then what else we want? Blue. For some reason I didn't record the blue there at the bottom. So 4/12 times by 3/11. That's 12/132, isn't it? Okay. And then you add the 2 together. Okay, add the 2 together. So that's going to be what? 68/132. 68/132. Okay, can you see it's not really the best chance of getting socks of the same colour, is it? So Jim's method is a bit flawed there. Okay. Part B, Jim selects 2 socks of different colours. This actually happens. When you're back at school, check out the teachers who like to wear socks of different colours. I've never seen the point of that. I've never seen the point of wearing 2 socks that are not matching. Not my thing. But who am I to speak? Because I'm not the fashionable one, am I? Anyway, that's what some people go for. So we want green, blue. So that's going to be 8/12 multiplied by 4/11, and that's going to be 32/132. And blue green is the next one, which is 4/12 times by 8/11. Surprise, surprise, exactly the same. 32/132. Can you see? You got 64 as a total there. 64/132. Okay. Now, Did you spot before I got to it what the quicker method was? If you saw one of the videos I played yesterday, I'll just remind you, okay, there is sometimes a quicker method, because if we've looked at him getting socks of the same colour here and here, what's left is getting socks of different colours. All of these probabilities must add up to 1, so all we had to do was subtract the first probability from 1, and that would have given us our answer. So that would have been a quicker way of doing it. Okay. Right, I hope you enjoyed the presentation of that as much as I did. Okay, and you'll be hearing from me again soon. Bye bye.